I will give you a very simple little example in this video. I will use sverchok to generate a model like this. This is a very simple landscape building. The structure of this model can be observed in the picture. The whole structure is an undulating ring structure. And the basic structure is composed of some rounded corners. Next, we import these two images into Blender. Now, we are back in Blender. I've gone ahead and used the information in the image to build a matching fold structure. Next, I'll use this fold as a basis. Modeling the Rounds Theater Pavilion in sverchok. First, let's go back to the sverchok operation window. In order to convert the folded objects in the view to rounded curves, we can use the fillet polyline node in the curve. Then use the Get Objects Data node to read the polygon data from Blender. Input the point data of this line into the fillet node. We will get a rounded curve data. The curve is a parameterized object. We can control its resolution however we want. Contrast the image. Set the radius of the rounded corners to a suitable value. Turn on the point display of the curve preview and you can observe that the curve is not uniform. To get a uniform polygon based on the input, we use the adaptive curve node to convert the curve to a polygon again. At this point, the transformed polygon is still not uniform. Next, reparameterize the curve using the curve length parameter node. Using the manual mode of the node. This mode will sample the curve based on the input curve position. Increasing the resolution will increase the accuracy of the node sampling. With these operations, we can get a uniform polygon. Here, we are ready for the next step. It is clear to observe that we need to extrude the polygon. This can be done by using the Extrude Edge node. Extrusion is controlled using a matrix. We will extrude a distance along the y-axis. Again, following Blender's modeling logic. Materialize the face piece using the materialization node. Adjust the parameters to set the thickness to the appropriate value. Look at this materialized object. I think it's a little sharp at the rounded corners. At this point I can still go back and adjust the resolution of it before. This is where procedural modeling comes in handy. You can always go back to one of the previous steps to adjust the state. Finally, using a simple deformation node. Bend the geometry around the z-axis. And we end up with the model we want.